Hi, this is Jason, and today I'm going to show you how to use our Traveling Salesperson Problem template. This problem is a canonical problem in computer science in which people have to find the shortest distance connecting a lot of different points on a map. So let me show you a quick demo to see the problem. This is a combinatorial problem with a definite solution. So it has a particular class of problem in which you're trying to find the best potential path. So what I'm doing here is I'm just going to try to connect these cities in the shortest distance I can. And here we go. So it's a little tedious. Take some time and some work to get used to. Oh, almost clicked the wrong button. There we go. Can I make it shorter than 497? So I can see my best. I can click it. Oh, I can load my best. There we go. Submit. And keep going until I find the shortest path. In this case, I'm not playing with other users or simulating other bots, but that's one of the options here. So what I'm going to show you here are the variables that you can use to try and customize this experiment. So anti-scale is just a scaling variable. The x and y axis on that map is on the order of 10,000 or 100,000 units. So this makes it a little bit easier to read. I think you saw my score was something like 479 rather than 479,548. The next four items are bot programming. The way bots work here is that we know where the shortest path is, and the bots are going to use that shortest path, but they're going to switch a certain number of edges. And so in this case, all three of these bots are set to switch 4 edges at random. So that's sort of close. It'll look kind of ugly. If you wanted to be a lot closer, if you wanted them to give really good answers, you would set this to 1 or 2. And this bot is really good at the beginning and then gets worse over time. So that's the bot programming. Bot swaps is the exact same thing, except it's what happens when somebody leaves the game early and you have other players still playing. The bot will pick up where the person left and it will randomly replace 4 edges. City radius is just how big the dots are on the map. Close score is how close you get to the correct answer in order to earn the star. There's an achievement built into this that you can turn off or on. Fail score, if you don't make a map by the time the round timer is over, the score basically is empty. So you don't earn any points for that particular round. So instruction duration, round duration, maybe one or another timer length here, but these are all just the amount of seconds that people spend in a particular part of the experiment. So 50 seconds to make a map, or 120 seconds to get through the instructions. Number of cities and number of rounds. Number of cities is the number of sort of dots in the map, and the way this works is we have a bunch of pre-built maps. These maps need to know what the right path is and how long that path is. So what you have here is we have a maps.js file that just has a bunch of maps. So here's map 0. So case 20 here on line 5 means there are 20 cities here in map 0, where city 1 is at 457.81. And at the end, you can see the list of optimal cities. Oops. It's a little small. At the end, there's a list of optimal cities, and then the length, the total length of the line. So this is the scaling factor helps you make this a little bit smaller. Human interpretable, human scale. So what you do is you just set this variable to num cities to one of those map sizes. So we have maps for 20, we have maps for 16, maps for 15 cities. If you want to create your own maps with your own number of cities, that's all you have to do is just tell it the right number of cities that you have, where they are on the XY axis, and the right path and the subsequent length. Num rounds is how many rounds people have to find the optimal path. Preferred maps is the order in which you should draw from these maps. So The first map in the row was map 0 and map 1, and this is just lining up to that. There's map 42, map 25. Round duration again, 50 seconds. Scale, again, we're multiplying the distance by this. Show map, show score, and show team modulo, or variables controlling multiplayer versions of this experiment. So if you have more than one person participating in this experiment, you can have them seeing one another's results. Aha! So this was set to 0, so I wasn't going to see anybody's results. But if I set it to 1, I'll see everybody's results every round. So at the end of round 1, beginning of round 2, I see everybody else's maps and how close they got. Well, I'll see their maps if that's set to 1, and I'll see what they got, their score, if that's set to 1. Finally, show instructions, true or false, is just disabling the instructions up front. And that's it. Once you have these variables the way that you like them, go ahead and demo the experiment, make sure that it works the way that you want. All of the data that gets created during the experiment comes out here at the end on the Export Data tab. You can also click this Export button to get a separate file. And that's it. If you have any questions, please let us know. Send us an email at support@volunteerscience.com. Thank you.